Friends, today we are going to build 5, 12, 15 voltage DC power supply. This is the schematic diagram we are going to use. The first component here is the transformer. This is the bridge rectifier. The type of filter we're going to use is the pi filter. So we are going to concentrate much on this because this part is the most important part. Guys, the first component here is the transformer. So we have the transformer. So the transformer is plugged to the main AC. Transformer is plugged to the main AC. Then at the output, we'll get here between any blue and white, you will get your output. So we are first of all going to measure the output of the transformer. Using a multimeter, we are going to measure the output voltage from the transformer. So guys, you can see that the output voltage from our transformer is 15.1 volt. Okay. That is the output from the transformer. Now we can move on to the next step is the bridge rectifier. So a bridge rectifier is made up of 4 components, 4 diodes connected into a bridge. So if you want to understand more about this, check in the description. I have put a link for you. You will go watch that video and you will understand more about bridge rectifier. At the output of bridge rectifier, we get DC power. So at this point here and that point, we'll get the DC power. So we're going to connect the transformer between this point and that point according to the circuit diagram. As you can see the circuit diagram here, this point and that point. So those 2 points are these ones. So you're going to connect the transformer whichever way you will connect it. So this is AC power. Now let's measure the rectified DC because the voltage gotten after the bridge rectifier is a DC power. So the measuring scale was in AC, now we bring it to DC. So guys, you can see that the rectified DC, the voltage after the bridge rectifier is 13 volt 0.35 DC. So this is the rectified DC from the bridge rectifier. Now, this DC still contain AC components, so we need to build up a filter circuit to get rid of the AC components. So we're going to remove the AC component which is still in that DC. In our case, we are going to use a pi filter according to our circuit diagram. So we're going to use the pi filter. The pi filter is made up of 3 components: capacitor, inductor, and capacitor. The 2 capacitors are connected in parallel, and the inductor is connected in series between the 2 capacitors. So these are the 2 capacitors. Okay, this is the inductor. So this type of capacitor, an electrolytic capacitor, you can see it is shown the negative and the other side is the positive. So the polarity matters for this type of capacitor. The longer pin is the positive and the short pin is the negative. Now let's connect our pi filter. Now guys, we have power at this point. Okay, we have power at this point. For us to be able to bring power here so that our circuit diagram looks neat, so we need jumper wire. So this jumper wire takes power from here, the DC rectified from here up to this rail. Okay, and this rail, and the same is done here down. This rail here takes power also the negative up to this rail. So this will allow us to connect the first capacitor effectively. Okay, so the positive side is there, the longer pin, and the short pin is there. It's down here. So you can see we have connected the first capacitor. So if you check our circuit diagram, this line coming from the bridge rectifier, the first capacitor, is this jumper wire here. This red jumper wire up to the first capacitor. The same is done here. This red jumper wire to the first capacitor, then connected to the ground. Then the next component is the inductor. So the inductor is connected in series. So if you check our circuit diagram, so it's connected, the first pin of the inductor, it passes through the inductor to the second pin and you get the output. So this is the inductor. So one side is going to be the input, another side is going to be the output. So for us to be able, so this line here, this line and that line is this jumper wire here, red jumper wire and this jumper wire. So we are going to plug our inductor to the circuit So our inductor is connected in series. Then, as the same we did for the first capacitor, we are going to do the same for the second capacitor. So at the output of the inductor, you can see this wire here. The output goes to the second capacitor. Then the output, so remember the polarity matters for electrolytic capacitors. So we have built our pi filter. So we are going to measure the output voltage at our pi filter. So guys, we are going to measure the output voltage from the pi filter. So this is the positive side and the negative side. So let's turn it on. So the output voltage from the pi filter is 20 volt DC. So this is the output voltage from the pi filter. We have 20 voltage DC. Now let's use the linear regulators. You're going to use as per the circuit diagram. Let's see. So we have 7805. We have 7815 and 7812. The 78 prefix means it's going to provide us a positive output voltage. So how are these components connected in the circuit? As you can see from the circuit diagram, this component has three pins. Pin 1 is the positive, the second pin is the ground, and the third pin is where we get your output. So the voltage measured between this pin and the output, the ground, you will get your output voltage. So we have connected all of these. Let's remove this one first. Let's remove this one. This is the meter. Then let's connect here. So you can see here. So this is 7805. This is 7805. This is 7812. And this one is 7815. So from here, from this output, we'll be measuring one by one. You will see the different output we'll be getting from different IC. So this output will be 5, 15, 12. So you can see maybe slightly, it cannot be exact, but it will be close to that, can be close or more to that, because remember, things made by human beings are never perfect. So let's test our power supply. Now let's measure the first component. We have turned it on. So the first one should provide us 5 volt DC. I've said that it can be close or more with some point, with the reason we gave. So the first IC is giving us 5.6 volt. So this is the 5 volt output IC. So if you have a 5 volt load, you can use from this IC here. Let's take the second one. The second IC should provide us 12 volt. Let's see what it has given. So the second IC has given us 13.4 volt. Okay. So this is the 12 volt output. Okay. So when you want to use the 12 volt, you can use this at this point here. Okay, then let's finish with the last one, the 15 volt output. Let's finish with the last one. So guys, you can see that the output is giving 16.9. I say that these ones, so when you see the voltage like that, because it's still on no load, so we are going to load all this output and see how they will behave. They are output. So we're going to connect some loads at the outputs of this power supply. So we have first output is 5 volt, 12 volt, and 15 volt. So you can see that we have made our power supply. Then let's now test by loading each output. But for now, I don't have a 15 volt load. Let me use for 12 and see what will happen. We have loaded the power supply for 5 volt. We have given an LED. We have connected a current control resistor in series with the LED. Then for the 12 volt, we have connected a 12 volt bulb. So let's test. So you can see this is for the 5 volt. You can see the 5 volt is lighting the LED, and for the 12 volt is lighting this bulb. So for 15, we can only get the output from the meter. Okay. So guys, that is our project. What can cause those readings? The meter is not accurate. The meter is the problem. But our experiment is okay. So if you still want to build one, you can follow this circuit diagram. Just see how you can screenshot and build yours. Follow for more to come. So that is what we had to discuss today. Thank you, guys.